Hey, how's it going, do-it-yourselfers? Today we're going to be going back to the basics and I'm going to be showing you how to properly use a multimeter. And we'll be covering how to measure DC voltage, AC voltage, resistance and continuity, and also how to measure amps. Alright, let's start with DC voltage. Basically the main source of DC voltage in the different devices that we use these days are going to be batteries. Or in other words, anything that uses batteries runs on DC voltage. For example, anything on your car that runs off the car battery, your wireless DeWalt drill, or any camera or camcorder that runs off a battery, they all run off of DC voltage. And if you're wondering, DC stands for direct current. And when you're using the multimeter to measure for DC voltage, you need to set your dial to this setting where you got a V for voltage and the straight and dotted line for direct voltage. And next, you need to make sure your test leads are in the right location. Now, your ground or common test lead is always going to go right here where it says COM. But the red test lead is the one you're going to be switching around based on what you're measuring. And for measuring voltage, you need to place your red test lead here where you see the sign, which is V for voltage. Now, as far as where you exactly want to set this dial when you're measuring voltage, you basically want to set this to the next number up from the maximum amount of voltage you're going to be measuring. So for example, if we're going to be measuring the voltage on this 1.5 volt AA battery, we're going to set our dial to 2 volts on the DC voltage scale. Next, we put our positive test lead on the power or positive side of our circuit, and then the ground test lead on the negative or ground side. And as you can see, we got 1.6 volts, which means this is a fully charged battery. And if you're ever unsure about the amount of voltage you're measuring, you can always start off higher, like we got here on 200, and then come lower to get a more precise reading. Now, if you're ever unsure and hook up your test leads the wrong way, you're going to see this negative sign next to your voltage reading like we got here. Now, this doesn't hurt the multimeter, and it's actually a pretty decent way of finding your positive and negative side of your circuit. Next up, measuring AC voltage. And basically, any device that plugs into your wall socket uses AC voltage. And AC stands for alternating current. And when measuring for AC voltage, your black test lead stays in the same place, obviously, and your red test lead stays in the same place, since again, we're measuring voltage. But you'll need to switch your dial from DC voltage to the AC voltage area, and you know that by this wave sign that's next to the V here. So next, we're going to see whether we have current at a wall socket or not. And since we get about 110 volts here in the States, we're going to set our dial to 200, which is the next one up from the voltage we're expecting to measure. All right, a word of caution. When measuring high voltage like this, you need to be 100% sure of the integrity of your multimeter, plus the wires that go to your test leads and the test leads themselves. Also, when you go to take your measurement, make sure your fingers are away from the tip of the test leads, but also when you get near the socket, that your test leads don't come into contact or near each other. So next, we grab our ground test lead, and we're going to put this in the bigger slot on our wall socket. And then we grab our red test lead, and we're going to put it on this other side, which is the power side. And as you can see, we got 118 volts coming out of this, which is about right. Also, if you ever wondered what this one is for, this is your case ground. And a good way to check it is to see whether you get a reading when you do this, and we do, so this is good as well. All right, next up, measuring resistance. And resistance is basically the amount of opposition that any substance has to the flow of electric current. So for example, this piece of wood is extremely resistant to the flow of current, whereas this wire has next to no resistance to the flow of electric current. Now, different components of an electric circuit are supposed to have a certain amount of resistance so that the whole system works properly, and that's where knowing how to exactly measure resistance is very crucial. Now, when measuring for resistance, your black test lead stays in the same place, and on this multimeter, the red test lead also stays in the same place because this horseshoe-looking thing is a sign for resistance. And we put our dial here where we get the scale for resistance. And for this example, I'm going to be measuring the resistance for this spark plug wire. And this spark plug wire is supposed to have a resistance of about 10,000 ohms. Ohms being the unit of measurement for resistance. All right, same as before, since we expect a measurement of 10,000, we're going to set our dial to the next number up, which is 20K, or in other words, 20,000 ohms. All right, here we go. And as you can see, we got 9.89 thousand ohms of resistance, or in other words, 9,860 or 870 ohms of resistance for this spark plug wire, which is about spec. All right, next, let's go on to testing for continuity. And testing for continuity basically means checking an electric circuit to see whether current can flow through it. And when testing with a multimeter, your multimeter sends a tiny amount of voltage through that circuit, and then continuity is verified, usually by an alarm or a beep. So for continuity, we set our dial here to this icon that sort of looks like a sound wave. And since we're still in the resistance setting, our test leads stay in the same area. So for example, if you wanted to make sure the wires that go to this connector are in good shape and that electricity or current can travel through them, you would attach one of your test leads to one end and then your other test leads to the corresponding pin on the connector. And if you hear that beep, that means you got continuity. And if you do this and you don't hear a beep, it means that you got a short somewhere in this wire, or in other words, in our case, maybe a cut or a burnt wire. Now I did this test on a rather small scale, but this can be done on a much larger scale, or in other words, larger circuits, or even smaller circuits than this, like a motherboard of your computer. A word of caution though, whenever you test for resistance or continuity, you have to make sure that the device is not powered, so either unplug it or remove the batteries. Next up, how to measure amps. Now when you measure amps on this multimeter, you need to switch your test lead from this slot to one of these. Now on this multimeter, this first one is fused, which means if you measure more than 200 milliamps, you're going to blow a fuse inside your multimeter, but your multimeter as a whole is going to be saved. But this second one is unfused on this multimeter, which means if you measure more than 20 amps, you're going to ruin your multimeter. Also, if you're unsure about the amount of amps you'll be measuring, but you know if it's less than 20 amps, you can always start with this higher one and then move down for a more precise reading. So for this example, we're going to measure and see how many amps this little light bulb uses. So we put our red test lead in this setting. And next we're going to set our dial, and since this light bulb is battery powered, we're going to set it to 20 amps on the DC voltage setting. And the way you measure amps is basically you place your multimeter on the power side of the circuit you're measuring. So here's the wire from the positive side of this battery. You place your red test lead closer to the power source, and then from there power travels through your multimeter, through the black test lead to the positive side of your device. And next, when we complete the circuit by connecting our ground side, our light bulb turns on and we get our reading, and as you can see, we got 1.95 amps. So it was a great move putting our red test lead on this higher setting to measure 20 amps, otherwise we would have blown a fuse here. And those were the basic functions of a multimeter. Hope that cleared things up. And if you found anything useful in this video, please give it a thumbs up. Also consider checking out some of my other videos where I use this multimeter to diagnose problems with my cars. I'll put them up on the screen as video links so you can just click on it. All right, thanks for watching. See you next time.